Hi everyone, welcome to the second lecture about functions. Functions, as I discussed multiple times, functions are one of the most important concepts in not only in programming languages but also in computer science. It's the most important abstraction in computer science. We learned F1VAE where functions are not values, first order functions. And then we learned FVAE where functions are values, meaning that functions can be passed as arguments to another functions, or functions could be results of function calls. So functions are values. That's the main difference between these two. And then we learned FAE based on the observation that function expressions and function calls can represent local identifiers. So local identifiers can be rewritten by function expressions and function calls so that we can replace that altogether and learned FAE. Today, we are going to briefly review this story one more time and then express that more clearly in mathematics, meaning operational semantics. After that, we are going to learn lambda calculus, the most fundamental calculus for programming languages. That's going to be the story for today. So let's review most important concepts that we discussed on Monday. And actually, they are really important in the sense that if you do not get functions as values now, it's going to be really difficult for you to study the remaining material. So today is really important. Today's lecture is really important. You are lucky that you are going to have this video for 1 week. And I strongly recommend you that if you do not get the material today, then you'd better do that by this weekend, I think. Because the longer it takes, it's going to be more difficult for you to get. So let's review. The language that we are discussing is FVAE. From FVAE, we have values that may not be numbers. Until then, before FVAE, until F1VAE, all the values were numbers. So the interfunction returned numbers. But now that functions are values, a function value needs to be treated as values. And a function value has some information. So in this language, in FVAE, we defined a new kind value. This is a type value. And this type value has two variants, meaning that value is either number, num_v, or closure v. Num_v is a number. Closure v consists of 3 pieces of information: the parameter name, body expression, and the environment when the function was being defined. We represent that like parameter name, body expression with some environment. So the environment sigma is a mapping, right? It's a map from names to their values. Names to their values, either numbers or closure. So when we have this kind of concrete syntax on expression in FVAE, this FVAE that's given, it's a parser which takes this expression in concrete syntax and converts that to abstract syntax. And this interfunction takes that abstract syntax and an environment initially empty, and then what's the result? Let's see. Oh, y's value is 10. And then this is a function expression. Function expression, its value is going to be closure v. So it's going to be clo v, whose parameter is x. It's string, so x. Whose second field is body, which is an expression. The body, which is an expression, addition, right? So addition takes two expressions, id and another id. id takes a string y, and then another id takes a string x. And what's next? That should take an environment. An environment. Which environment? The empty? No. When this function expression is being evaluated. Do you see that? What's that environment? That's the environment. On top of the empty environment, this information y is 10. So the result of evaluating this expression is closure v with parameter x, body expression addition, and the environment on top of this empty environment, it includes this information saying y's value is 10. This map is a mapping from strings to values, names to their values. Name is y, string y, its value is 10, not integer but value. Value meaning not clo-v but num-v, so it's gonna be what? A mapping from this string y to num-v10. Is it clear? Even though it looks really simple and it looks so obvious, I strongly recommend you to do that by yourself. From this one, yeah? You should be able to write down this. It's really easy. I mean, it should be really easy. That should be the easiest problem in your midterm exam or quiz, for example. You should be able to do this by yourself. Okay. Then, as I said before, with F1 VAE, where functions are not values, this inter function returned an integer. Because evaluating an expression should result in an integer number, not a closure v. Because in F1 VAE, functions are not values. So this inter function takes an expression to evaluate, an environment to look up the values of names, and a list of function definitions. And in the function call, function should be a name. So using the name, we look up the definition of the name. And when we evaluate the function body, the environment should be what? On top of this empty environment, the parameter has its value. That's it. When we evaluate the function body in F1 VAE, the environment should have only one piece of information. Because in the body, the only possible identifier, valid identifier, is a parameter. But in FVAE, because functions are values, inter function now takes an expression to evaluate and an environment to look up the values of names without FDs, because function definitions do not exist in FVAE. And when we call a function f does not need to be a name. In FVAE, 이거는 꼭 이름일 필요는 없어요. It does not need to be a function name. At the same time, function expression일 필요도 없어요. This one does not need to be a function name, a function expression. This could be an arbitrary expression. 이거는 어떤 expression도 올 수 있어요. If it's an addition, subtraction, or number expression, or function call, or some other thing that may evaluate to a num-v, it's an error. 이게 그냥 임의 expression인데 계산했더니 num-v가 나오면 그냥 error예요. When we interpret the first of expression and its value is not clo-v but something else, which is num-v in this example. Why num-v? Because there are only two kinds of value. clov or num-v. If it's not clov, it should be num-v. If f's value is num-v, it's an error. Yeah, we are calling a function and the value of the first sub-expression is not a function, then that's an error. What if it's really clov? Oh, that's good. We are expecting a function here which has a parameter name, body expression, and an environment when that value clov was constructed. Then, yeah, we are going to evaluate this argument expression, the second sub-expression, get the value, and pass the value to its parameter. So we interpret the second sub-expression under the given environment, and the value of that should be the value of the parameter. When we interpret this body expression B, when we evaluate this body expression B, when we encounter the parameter name X, then the value of X should be the value of the second sub-expression. So far, so good. On top of what? Again, here, there could be several options. Is it like, yeah, empty environment? Or is it going to be EMV? Is it going to be FEMV? Or some others? Yeah, there could be some other environments of the type EMV, but they are all crazy if they are not one of these three. Even two of them are crazy, right? Let's see. If we put this information, parameters value, on top of just empty environment, just like this F1VAE, yeah, it worked. It had to be empty environment for F1VAE because what? Functions were not values. Functions were defined on the top level, FDs. They cannot be inside any other function expressions. They cannot be inside any other function definitions. They cannot be inside of any other local identifier introduction. They should be always on the top level, meaning that their function bodies cannot have any free identifiers. So that should be empty. But in FVAE, function expressions like X arrows body expression B, they may be inside some other function expression or they may be inside some other local identifier declaration like val C equals 42 semicolon like that, meaning that this function expression may be embedded. They may be embedded inside some other expressions that introduce names, and those names may be available inside this body expression. That's why function expression, the function value clov should include FEMV. That's why this FEMV may be different from this given environment EMV. Right? Do you see that? So you should be able to identify the differences between these things. What things? Empty environment, and F environment. Empty environment meaning just empty blue box. Remember? EMV meaning the environment at the function call site. The environment at the function call site meaning dynamic scope when the function is being called. And FEMV meaning what? The environment that was captured when we construct this closure V, meaning when we construct a function expression stated. Is it clear? Not yet? Let's look at another example. What is this example? Yeah. As before, we'd like to compare this environment at the function call site and this environment when the function was being defined. Let's see. Here, from here to there, we are introducing a local identifier y whose value is 4. Okay? And then, so y is 4 is available when we interpret this expression, which is a function call. This is a function expression, closure V. This is second expression, argument 10. When we interpret this function call, we are gonna interpret this function body expression. When we interpret this function body expression, what's gonna be the environment? Compare this with another example saying from here to there. Oh, we are introducing function expression first here. Its parameter is x, body is y plus x. What is y? What is y? What is y here? Do you see the difference? You should be able to see the difference. In the first example, when we evaluate this function expression and construct clause V, do you see the point? When we construct clause V, we have parameter x, we have this body, and environment. In the environment, y is available. Y's value is 4, right? When we construct clause V here, it's going to be clause V, parameter is x, body is going to be that again, and the environment is what? Empty. Y's value is not available, right? So one evaluates to a value, the other evaluates to an error. So I will not go into the details because that's your job to identify this, okay? You should be able to see the difference between these two examples. Finally, not really finally. Again, we discussed this on Monday, but I'm going to repeat this for you one more time. No more val. We are not going to have this local identifier declaration anymore because that's exactly the same with this one. Locally introducing a name with the value of this first expression and evaluate the second one, that's just the same with function call with this parameter and switch the order of two expressions. Meaning that when we evaluate this expression first and remember that this ID has the value of this one and evaluate this thingy, is just the same as this is closure V. Evaluate this expression first. Remember that the name ID has the value of x plus 1 and then evaluate x plus 2. They are just the same. So we can say that, the result of evaluating val ID x plus 1, x plus 2 is just the same as the result of calling this function expression ID whose body is x plus 2 with the argument x plus 1. Okay? So say when I give you some example like val y equals some complex expression e1 and then e2, and I can ask you like rewrite this example without using val expression but only with function expression and function call. Then you should be able to rewrite this. How? Like this. Y, let's call this just E1. Y and what? What do you think? E2 and open E1, right? And in a concrete example, these Y, E1 and E2 are going to be some complex expression so that you should be able to write that. Said enough, right? Finally, let's move on. So we grew the language VAE to FAE so that, not only the identifier introduction, we have functions as values. And FAE, concrete syntax, is the usual thing, arithmetic expressions, name, function expression, and function call. And there's no surprise to implement that in Scala. Expert is either arithmetic expressions ID, function expression, and function call. Right? I will switch it the order because it's function call and function expression. This one is function expression and function call. No, nothing really serious, but they are different order. And values again, yeah, value is either NumV or ClojureV. And interpreter, we saw this before on Monday. Let me stop here. I just, repeated things too many times. Then, finally, beautiful mathematics. What did we define until now? We defined FAE, arithmetic expression with functions. Arithmetic expressions with function thingies. What are function thingies? Identifiers, function expression, and function call. Identifier is a name. Identifier is just a name. In Scala, just string. Function expression, meaning it's an expression which has a parameter name x and body expression. So when we say this, it's called Greek letter lambda, lambda x dot e, saying that it's a function expression. It does not have a name. It's an anonymous function. It's an unnamed function with one parameter named x, whose body is this expression. So in concrete syntax, how did we write it? We wrote it like x arrow e, right? This is concrete syntax. This is abstract. Abstract syntax in mathematics, in operation semantics. And how about this one? This is function call. Again, in concrete syntax of FAE, we wrote it like E open E. But in this mathematical notation, function call is going to be EE. And the values, I already showed this to you before, but one more time. A value is either number or ClojureV. A value is either NumV with a number or ClojureV. ClojureV with parameter name, body expression, and the environment when the function was being defined. An environment is a finite mapping from names to values. Value now is not only the set of integers, but also the set of closures. So clo-v meaning closure value. What is closure? Closure is a pair. This one represents a pair. 쌍을 말해요. 순서쌍 pair, which has an expression and an environment. So this one says set notation, set product, meaning a pair of expressions and environment. Actually, closure is not a pair of arbitrary expression and environment. It's a pair of lambda expression, function expression, and environment. But we are abusing the notation because we can even say this like lambda, it's yet another set, which is a subset of expert, and that's actually what? Only lambda dot x dot e. We can do that and make this as lambda. We can do that too, but it's more precise, but requires yet another set. So we are abusing the notation and saying that closure is a pair of expressions and environments, and that expression should be a lambda expression, function expressions. And using this notation, we are going to define the semantics of FAE in mathematics, meaning the operation semantics. So let's take a break. This is the first part about functions, and we are gonna talk about functions even more for the second part of today's lecture.